Okay, so page number 7. The rectangle struct below has two properties, one for width and one for height. Add a computed property that computes the area of the rectangle, width times height, create an instance of rectangle, and print the area property. All right, so let's see how we're going to do that. So we've got a rectangle struct with width and height set as ints. So all we're going to do is we're going to create a new property, right? A computed property called area, and it's going to be of type int, and it's a computed property, and essentially it's going to return, it's very easy, it's going to return, you ready for this, width times height. So whenever we print area, it's going to take whatever width is, it's going to multiply by height, and it's going to return the total. Okay, so let's go ahead and see if that works. So var sum rectangle equals rectangle, and we're going to initialize it with a width of 10 versus and a height of 5, let's say. And if we go ahead and we go print sum rectangle dot area, it should say obviously 50 because 10 times 5 is 50, and yes, it does. Pretty easy. So that's what a computed property is. Okay, very simple stuff. All right, moving on. In the height struct below, height is represented in both inches and centimeters. However, if height in inches is changed, height in centimeters should also adjust to match it. Add a didSet, okay, to each property that will check if the other property is what it should be, and if not, sets the proper value. If you set the value of the other property even though it already has the right value, you will end up with an infinite loop, of course, of each property setting the other. So that's a nice warning that they give us here. Create an instance of height and then change one of its properties. Print out the other property, ensure that it was adjusted accordingly. Okay, so that's a mouthful, and I'll explain what's happening here. So they've given us a struct of height, two variables, height in inches and height in centimeters, and they've initialized height in inches and height in centimeters. However, they want us to make it so that as soon as we change one of the values here, the other automatically changes without having to initialize the other, just automatically changes. So how do you do that? So we're going to create a didSet. Okay, so we're going to add the didSet property, and this is not so hard, so I'm just going to make some space here. So var height in inches, we're going to add two curly braces, right? And then we're going to do a didSet, so you type in didSet, and that's a keyword, and then we're going to add another two curly braces because we're going to write some code in the didSet. And by the way, this is called a closure. Okay, so you could watch my video on closures to know what a closure is, but essentially it's like a block of code. Think of it as a function, but it's not quite. So that's a different video. So let's go ahead and write some code. So I'm gonna go let value should be in cm, centimeters, equal, I'm gonna explain what I'm doing here, height in inches times 2.54, and then I'm gonna say if height in centimeters does not equal value should be in cm, then and only then height in centimeters, give it the value of should be in centimeters. Okay, and I'm gonna essentially do the same thing for this except reversed. So did set two curly braces, and I'm gonna say let value should be in inches equal height in centimeters this time divided by 2.54. Great. I'm gonna say if height in inches does not equal value should be in inches, then and only then give height in inches, the value should be in inches. Okay, so let me explain what's happening here. You have to understand this is the same essentially thing but reversed, but let me explain this and I think it'll be very clear. So these are just simple properties, height in inches and height in centimeters, and they have them initialized here. So essentially what we're doing here is we're saying, listen, the didSet. So the didSet property that's built into structures essentially looks at the value changing, and it's an observer. And as soon as it observes that this value changes, you could tell it to do some code. You could tell it to do something based on the fact that it observes something has changed here. It sort of triggers it, okay? So it's a triggering effect. So as soon as the didSet observes something has changed here, we're doing the following. We're creating a constant and saying value should be in centimeters. So we're saying, listen, we created this empty constant and we said whatever the height in inches is, whatever it is, multiply that by 2.54 and put it here, okay? So let's say, just for argument's sake, height in inches was 1, okay? So times 2.54, this is going to be 2.54. So we're saying if height in centimeters, if this is not 2.54, if this is not the same as this, and only if this is not the same as that, so only if this value does not equal this value, then give this value to that. And I'm essentially doing the same thing here, but in reverse. Now, why do I have to put this if statement? Why don't I just say this is the only line, or rather only put height in centimeters equal height in inches times 2.54? That'll save us 3 lines. Why did I do this whole complicated thing? Because of this line right here. So they give you a warning. If you set the value of the other property, even though it already has the right value, you will end up with an infinite loop, because the didSet observes any changes even if there is no change. I know that's weird to say. So let's say you have a property, let's say height in inches, that has a property value of 1, and you set it again with the same value, a value of 1, this will be triggered. So you don't have to change the value for this to trigger. This will trigger whenever something new is set, even if the new value is the same as the old value. Okay, well, what's the problem? Well, if I go ahead and give this value, change this value to this value right away, what's going to happen is this is going to trigger and it's going to give the new value to height in centimeters. But then this will trigger and it'll give the new value to height, and then it'll go back and there's a new value here. And then this will trigger and give this a new value, and then this will trigger and give this a new value, and then you'll have a infinite loop of each property setting each other. We do not want that. So that's why we put this simple if statement check that only set the other value only if it currently does not have the correct value. And that's essentially it. Now let's see if this works or not. I'm pretty sure it'll work, but better check. So we're going to create var sum height equals height, and we're going to set let's say inches, and we're going to give it 10 inches. Okay, cool. So we've initialized sum height of 10 inches. So if we go ahead and print sum height dot height in inches, it should obviously say 10. If we print height dot height in sum height dot height in centimeters, it should say the equivalent of 10, whatever that is. Give it a second, and Xcode froze. Okay, and we're back here. Xcode had hang there. Playground does this all the time, where it says running and runs forever. But essentially, so we initialize sum height with height in inches of 10, and we printed it and said 10, and the equivalent in centimeters 25.4. That's nothing special. That's actually this code right here. They've done that for us. What we've done is when we make a change. So right now I'm going to go ahead and make a change. So I'm going to go sum height dot height in inches. Remember we set it as 10. I'm going to change it now to 20, and I'm going to print sum height dot height in inches. It should say 20. There's nothing special about that, but this will be the special thing that we kind of wrote, sum height dot height in centimeters, and it should change to whatever the equivalent of 20 inches is. and 50.8, right? So we initially set it at 10 and we printed the height in both, and it was 10 and 25. We changed the height in inches to 20. We printed it, obviously it's at 20, and surely enough, the equivalent in centimeters was also automatically changed because of the didSet here. And if we had done that, with centimeters and vice versa, it would have worked as well. All right, that was pretty cool. All right, moving on to the next page, page 8. All right, page 8. So let's get started here. Okay, so let's have a look. This is a short one. The running workout struct below holds information about user's running workout. However, you decide to add information about average mile time. Add a computed property called average mile time that uses distance and time to compute the user's average mile time. Assume that distance is in meters and 1600 meters is a mile. Create an instance of running workout and print out the average mile property. Check that it works properly. Okay, so how do we do that? So we've got the three properties and they want us to add a computed property. Well, that's really easy. So var, and the computed property is called average mile time. So average mile time, and it's of type double, and our curly braces, and we're just going to return time divided by, and a mile is 1600, so distance times 1600, and that should do the trick. So if I go ahead and create a new instance, so I go var my current workout, for example, and I make it of type running workout, and I'll initialize it with, I don't know, let's say 5 kilometers, so that's 5,000 meters. Time, I think the average is 25 minutes, and elevation 200 meters. Okay, and if we go ahead and now print my current workout dot average mile, see that we've got the computed property right here. So if we print that, it should say what it is in miles. So my average is 8 miles. 8 minutes a mile. So that's not bad. That's not bad. Okay, cool. Moving on. In other app exercises, you've provided encouraging messages to the user based on how many steps they've completed. A great place to check whether or not you should display something to the user is in a property observer. In the steps struct below, add willSet. Okay, cool. So this is a willSet. Okay, to the steps property that will check if the new value is equal to goal, and if it is, print a congratulatory message. Create an instance of steps where steps is 999 and goal. Got it. Okay, so willSet is another observer, just like we've done before in the didSet. Okay, so let me explain something. DidSet is an observer that will be executed, will be triggered whenever a new value has been given to a property. Okay, has already been given. That will be triggered. willSet will be triggered before. willSet will be triggered just before the property has a new value, just about to have a new value. So this will be triggered first, then the property will have a new value, then didSet will be triggered, just so that you know the order. So how do we go and do this? Okay, this is actually pretty easy, but you have to wrap your head around it first. Okay, so let's have a look at how we do this. Okay, so let's go ahead and get started. So it says in the steps struct below, add a willSet. So in the steps below, we're gonna add a willSet. So we put the two curly braces here and we type in willSet. And what are we gonna do here? We're gonna add two more curly braces and we're gonna add willSet to check if the value is equal to goal. Well, that's pretty easy. Okay, so we go if goal equals to new value. Now let me explain what this is in a second here. Let me just go ahead and print something here. Congrats. So I've explained how the willSet will actually set how the willSet will actually set. It should be equal because I'm checking for equality here. I'm not assigning a new variable. I explained how willSet will actually be triggered before a property gets set with a new value, and then the property will be set with a new value, then didSet will be triggered. When willSet triggers, Swift automatically makes two variables that you don't see called new value and old value. New value is literally will hold the new value that got set, and the old value will hold the old value. So here I'm checking whatever the variable got, the new value that it got. Let's check if the new value is equal to our goal. And if it is, we're going to go ahead and print congrats. Okay, so let's go ahead and do that. So I'm going to create, I'm going to say my workout today, and we're going to set it as an instance of steps, and we're going to initialize it with 9,999 steps, and our goal is 10,000 steps. Okay, and yeah, okay, that's great, nothing happened. But check this out. As soon as I go my workout today, as soon as I go and actually execute this function, well, what does this function do? This function it will automatically increment the steps by 1. So it's currently at 9,999. As soon as I execute this function, it should go to 1,000. Since this function is modifying the steps variable, this will automatically get triggered and do this check. And as soon as it does that check, it's going to say, yeah, the new value, 9,999 plus 1, the new value of that is 10,000. And yes, it does equal, it does equal goal, which we've set as 10,000. So it should print out the word congratulations. Let's go ahead and check. And it does automatically. Cool. All right, let's move on to the next page. All right, page 9. So let's have a look at this. Imagine you have an app that requires the user to log in. You may have a user struct similar to that shown below. However, in addition to keeping track of specific user information, you might want to have a way of knowing who the current logged in user is. Makes sense? Create a current user type property on the user struct below and assign it to the user object representing you. Now you can access the current user through the user struct. Print out the properties. Okay, so what they're asking us for here is create a current user type property. When they're asking for type property, they're not talking about instance properties, they're talking about type properties that belong to the struct themselves. So Swift supports adding type properties and methods which can be accessed or called on the type itself. Okay, so to do that, we actually have to use the keyword static. So static var, and they're telling us to create this property called current user. So we're gonna go ahead and create current user and set it of type user. So type user is actually the struct. So current user is going to be of type user. Okay, and we're going to initialize it with user, and we're going to give it some values. So username for the sake of logic, email no, it's a string, no email at apple.com, and age 31. Okay, and that's essentially it. Now you can access the current user through the user struct. Okay, perfect. Something to know about what we call type properties and type methods actually too is that you don't need to create an instance of user to actually use it. So these properties here are instance properties, right? So in order for you to use these, you actually have to make a object. You have to make an instance of user, like some user, to actually access this. To access this, you don't need to do that. You could actually just access it using dot notation. So how do we do that? If I just go print and then, well, my thing is called user, right? The structure is called user. As soon as I press the dot, it shows, oh yeah, there is actually a property a property, a type property called current user. If I go ahead and do that, it'll actually print, for the sake of logic, email and age. All right, cool. That was easy. There are other properties and actions associated with a user structure that might be good candidates for type property or method, right? That's what I was talking about. We could add type properties or methods, just like we could add instance properties and instance methods. We could add type properties and type methods. One might be a method for logging in. Go back and create a type method called login user, where user is of type user in the body of the method. Assign the passed in user to the current user property and print out a statement using the current user saying that the user has logged in. And then below, okay, so how do we do that? So we've created a type property. Now we're gonna create a type method. So again, anything that is type based is gonna start with static, and we're gonna create a method. So func, and it has to be called login. Okay, so we're gonna call it login, and it's we're gonna the parameter name is gonna be called user, and it's of type user, right? This might be confusing to you, so I'm going to change this. This is just a label. You could call it whatever you want. So I'm going to call it current logged in user. You could call it XYZ for all you care. This is just a label, right? Great. And what do we have to do? Where users and in the body assign the pass. Okay, so now we're going to assign this. Okay, so how do you do that? So current user equals current logged in user, which is this, right? So whatever someone puts in here, right, we're gonna assign it to this guy right here, and then we're gonna print a statement. Well, we're gonna print a statement here. Okay, so what are we gonna print? We're gonna print I don't know, let's print something like well, first of all, current user dot username, and we're gonna say is the one who is currently logged in, right? So now any new created instance, you could actually if you call this function, you could replace that new instance with this static instance that we've made. So below, call in a login user method and pass in a different user. Okay, so here we're gonna test out our method and hopefully it works. So we're gonna create a new instance. So we're gonna create my new user, right? So we're just creating a new instance like we've done many times before, and we're gonna give it some property. Well, too many quotations. We're gonna say this is fake for the sake of logic. This is not the real for the sake of logic. I'm gonna say fake email at apple.com, and 31, the inverse of 31 is 13. So we've created a new instance called my new user of user, and now we're gonna print it. We're gonna call this method here, okay, the static method. So to do that, we're gonna go user dot login, sorry, uppercase U, that's why I didn't see it, login, and for the current user we're gonna say my new user, right, that instance. And as soon as we do that, it should print something out, and Xcode froze once again. Sorry about that. And here we are. I just launched Xcode again because Playground had hanged, but surely enough, it printed. For the fake for the sake of logic is the one who is currently logged in, because this method, right, login method, has been called, and we took in the whatever instance and we've replaced it with our current user static variable. All right, last page, let's do it. All right, let's look at the last page. In another exercise, you added a computed property representing the average mile time from a run. However, you may want to have a calculator of sorts that users can use before their run to find out what mile time they need to average in order to run a given distance in a given time. In this case, it might be helpful to have a type method on running workout that can be accessed without having an instance of running workout. Add to running workout a type method mile time 4. And then I guess two labels, distance, two variables, two parameters, distance and time. Where distance and time are both of type double, this method should have a return value of type double. The body of the method should calculate the average time needed to cover the past in distance and the past in time. Assume that distance, okay. So it's essentially we're doing the same thing as we've done before, but this is going to be a static method. Okay, so how do you do that? Again, so type in static and func, and we're going to call it mile time 4. So mile time 4, and it's going to have distance of type double, and it's going to have time of type double, and that's pretty much it. But it's also going to be returning a double. Okay, and what are we returning? We are returning, just like before, time divided by distance times 1600. And that's pretty much it. Call the method from outside the struct and print. Yeah, okay, sure. So we could do that. So just to check it out, so print, and we're gonna print running workout dot mile time 4, and essentially this is a calculator. It says, okay, well, how much? See, recognize that we haven't created an instance here, right? So what do you want to run here? Let's say we want to run 7.5 kilometers, which is 7,500 meters. And the time I'm going to run it in, let's say I'm pretty fit, I'm going to run it in 35 minutes. And my mile per is 7.4 miles. That's not, sorry, 7.4 minutes per mile, right? That's not bad at all. Almost 7.5 minutes a mile. Not bad. Okay, cool. It may be helpful to have a few type properties on running workout representing unit conversions, i.e. meters to mile, feet to meters. Go back and add a type property for meters in feet and assign it 3.2, and then add a property. Oh, okay. So here they're just asking for, in case someone wanted to, didn't know what the conversions are, you could tell them what the conversions are and make it static. So static var meter in feet equals 3. What was it? 3.2 something. I forget what it is. 3.2 8084 8084, and static var mile. Yeah, there we go. Mile in meters, and that's an easy one, 1600. Okay, 1600.0, let's call it, because it's of type double. All right, and then add a type property, print both of these values. Okay, well, that's easy to do. All we're gonna have to do is print, and we don't have to create an instance, so we're just gonna go running workout dot meters in feet and print running workout dot mile to meter, and that's essentially it, and we're done. All right, that's page 10 out of 10. Thank you for watching.